Okay, good evening everybody. So let us start our review lecture this evening, and today is April 22, right? So as our schedule, we see that we have we are at the end of this semester, almost at the end of this semester. Okay, and actually in my last lecture I completed the course modules. All of the modules I completed. Okay, so in the last time I did not see any slides for tree and graphs. So today in our meeting we discussed this, and I heard that it has been uploaded here. So I think there is a slide. So module 9, this is linear data structure. It should be about tree and graph. So actually in my last lecture I discussed tree and graph based on my algorithm analysis course content. Okay, so before I go there, okay, so actually there is no enough content. So already I discussed this in my last lecture, but so I can finish up early this lecture tonight. Has anyone any question? Before I go here, has anyone any question? Do you have any question? So everybody is good. So no one has any question? Okay. So let's review this. Actually, I discussed this in my last lecture. Okay. So so these are non-linear data structure. Okay. Non-linear means they do not stay data element do not stay together one after another, but actually they are organized somehow, how they're linked, but they are organized in different ways. So there are several non-linear data structures. The two of the primary non-linear data structures is called trees and graphs. So tree, you can remember this is upside down tree. Okay. And then we will discuss graph. Okay, so okay, so there is similarity between trees and graphs, that all trees are graphs, but all graphs are not tree. Okay, so if a graph is a cyclic graph, that means all nodes are connected, then it is not a tree. So I will come this. Okay, with example. And recursion is used as I discussed, that recursive process is used for implementing data structure. Almost all data structure that we discussed earlier, linked list, stack, and queue, use this recursive process. Okay, so as we discussed, a tree. So tree is okay. So it has a single parent and 0 or more children, and a node with no child is called a leaf, and the topmost node is called the root, and it can be an n-array tree, or actually we discuss binary tree. So binary tree, so if a tree has only a tree is consist with nodes, right? If a node has only maximum number of two children, then it is called binary tree. So in the last lecture I discussed binary tree. So let us see if there is a picture here. Okay, so binary tree here. Okay, So in a binary tree, there is this is called so root, and this is a child. We say this left child, this is right child, and this is left child of 8, and 15 is the grandparent of 4 and 10 and 20 and 30, and these are all the lower level. These are leaves. Leaves means they do not have any more child. Yeah. So how do we implement trees? So actually we are not discussing coding conversion, coding implementation, but it's actually in previous semester we discussed coding implementations. So if you are interested to see how do we code for trees, so BST. So BST implementation, I have my program from previous semester, BST implementation example with C# and Java also, I have programs. So you see that internally a tree is built like with a node, so that is more similar with linked list, right? This node. Okay, and then it has some methods. So these methods are more similar with the linked list tag and queue method, and it has insertion. So recursively insert method, and it has traversal, in-order traversal, pre-order traversal, post-order traversal, and delete method. And this is, so I think for your test we do not need this, but if you are interested in, just I'm sharing my code with you. So this is Java C#, and I have also Java. I'm sorry. Okay, so our detailed implementation, actually we don't need this. Give me 1 second, let me turn on the lights. Give me 1 second, please. Okay, so the main these are the features. These are the features of binary search tree. Binary search tree, that as we discussed, that for every node, if it has any child, then maximum of two children. Okay, so here, so this is, for instance, this is a test question. So this is previous semester test question like this. So this is my data set, and we want to build a tree manually. Okay, so then no any program code. So we considering 15 as a node, as a root. So this will be 15 as a root. So 15 will go top, and then so starting from 15, if we say any element from right greater than 15, then it will go right side. So 25 will go right side, and then 8 will come to left side, and then 4 it will come to left side of 8. Then 10 is greater than 8, so it will go right side. Then 30 is greater than 25, so it will go right side of 25. And 20 is greater than 15, so it will go right side. And then less than 25, so it will come left side of 25. And 6 is less than 15, so it will come left side. Less than 8, come left side. And it is greater than 4, so it will go right side. And if you go this all the way in, then you will see this will be a binary search tree. So the binary search tree, it has some features. One of the features is that there is no duplicate elements. and all element in the right side is greater than its left side. And so in data structure, so this could be a pictorial view of a BST. Okay, so a BST is balanced tree. Is balanced tree, that means you see that its height, actually height is log n. Height is log n. Actually, a log n is base 2. So sometimes we say LZN. LZ means with base 2. Okay, and ln is natural log with base e. Okay. So a BST is a pretty balanced binary search tree, but it's not guaranteed that it will be a balanced. If a BST is a balanced, then it has then then adding an element will take big O log n. Actually, you will learn this in algorithm analysis course, okay, and our data structure course, not in this course about it's big O notation. This notation is used to determine or depicts the efficiency of an algorithm. So in case it is unbalanced, for instance, unbalanced, that means, for instance, if I have element 15, 25, 30, 36, 46, like this, 56, 70, like this. So all element will go on the right way. So left side will be empty, right? So if I would have some element, 25, then 30th, then 36, okay, then 48, something like this. Then all element will go on right side. Or even I would have, if I have element, all element goes in the left side, then it could be an unbalanced tree. So in that case, the the insertion and element, it takes big O of n, not log n. Because in order to insert an element, for instance, here 48, you need to go all the element. We need to jump all the element. We cannot, in a tree, that limitation is that we cannot go at any position, any node. We need to start from root and go down one by one step. Okay, so there can have so here binary, that means each node has two children maximum. There may have more than 2 children, but there are not. We are not discussing this this module. Okay, now graph. So graph is another data structure. The most common use of graph is to develop GPS system. So in a GPS system, for instance, each of these are cities. Like Marietta, this is Kennesaw, for instance, this is Roswell, and this is Alpharetta. Maybe this one is down Atlanta, Doraville, Snailville. These are the actually maybe some cities. Okay, so locations. So if you want to, there are connecting roads. For instance, let us consider that these roads are straight. Usually roads and highways are not straight, but we consider this. So so whenever we use a GPS system, the behind all of the GPS systems, so the graph algorithm is used. Sometimes we look for the shortest distance. Okay, so for instance, we want to travel from 7 to 10. So what should be the shortest distance? So it should be here 7 to 11, 11 to 10. But there could have multiple other ways. Okay, so for instance, if there is an accident and on the way 11 to 10, then we can use multiple other directions, for instance 7 to 8, 8 to 8 to maybe 3 to 10, something like this. And here you see the direction. Some graphs can be two kinds. One is directed, another could be undirected. Directed, if there is an arrow, that means only you can go from 7 to 11. You cannot go 11 to 7. This is directed. And for undirected, if there is no arrow, then you can go both ways. So graph is used, widely used for implementing horizontal graphical data structure that we use a GPS system. And in our last lecture, I discussed that there are three kinds of traversal, trees traversal. It is called pre-order, in-order, and post-order. Pre-order means the route we always, by consider in the context of route, we say root element. Whether we will consider the root element, we will jump to the root element, explore the root element first or last or middle. So if pre-order means we generate, we traverse the route first. In order means route will be in between left and right side children. And post order means we will explore left child, then right child, then root. So here in this example, if we let me see if there is any pre-order. Okay, so we have so we have here. So maybe there may be a test questions. Okay, you may get a test question from this slide. So for instance, if you are given a graph like this, okay, so in order traversal, that means in order means you remember that. So left, so remember here, in order means left, root, and then right. T order means root, RT means root, left, right. And post order is left, right, root. You see that? This may be a quiz question. So never the right comes first. The right node, right child can never come first. Okay. So in order means the root or parent will be in middle. Okay, root means parent over here. So always we need to start from in order. We need to start from all the way end. So then 2, 4, 6. Okay, then we need to go in order means we complete here. Then we need to go right subtree before we go to the root. So then 4, 2, 4, 6, then 9, 10. Oh, sorry. So 2, we said 2, 4, 6, then we complete this left subtree, then we need to go root. So here 2, 4, 6, 8, and then again 9, 10, 12, then 15, and then again 17, 20, 24, 25, 28, 30, 36. So you see that in order traversal always keeps us in ascending order. Okay, and pre-order means we will always consider the root first. So 15 is the root, we will go first, then 8 is the root, then we will come first, then 4 is the root, then we will come first. Okay, then we have 2 and then 6 and then 10 on the right side, 10, then 9 and 12. Then on the this side is 25, then 28, then 17, then 24, then 38, then 28, then 36. This is pre-order. Post-order means the root will go all the way. So this will go all the way end. So this root will go after children. So 2, 6, 4. Okay, then 9, 12, 10, and then 8. And then here we will not go to root again, and we will go right side. Then on the right side, when you come on the right side, we will not consider root. We will not consider root. We will go child first. So 17, 24, 20. Then 28, 36, 38. Then we need to go backward. 25 and 15. Okay, at this point, has anyone any question? Do you have any question?
No.
Okay, thank you. So these are some code snippet how to implement a tree. So, but I already shared my code, complete code. Okay. And this is apart from a game. So some of our students develop a game. So maybe if you take a game development course, then you need to understand tree structure, graph structure clearly, so that it'll be easy. Then you can implement this kind of games. And this is the use of graph. Okay, graph technology that is behind these graphs. So for map, implementing any map, we use this. So that's all from this slide. This is the last one. Okay. So if you don't have any question, then what you can do let me quickly review our go to our schedule. Let's see. So according to our schedule, our final exam will be at our section on May 6th, 3 p.m. to 11 p.m. Okay, so you will take it from home, okay? And if you have any conflict about if you have any conflict in your final exam with another final exam, then please let us know, okay? Otherwise, this dates and schedule is firm. There is no change. Okay, has anyone any question?
I know it's asked frequently in the group chat. Is there going to be a practice test at the final?
Okay, I will check. I will check. I no longer serve as a course coordinator because I moved in computer science department. So there is a new course coordinator. I will ask him if we have, and then I will post it. Okay. So please do not forget the remaining quizzes. Okay. If you take all quizzes, then one of your lowest test quiz grade will be dropped. But if you miss it, right, then the last one is 0. Then it will not help you. Okay, if you don't have any question, then I want to wrap up. And then what I want to do, I want to spend a few more minutes. Then I will upload this lecture video tonight, right now. I'm in office. Before I leave, I will. Okay. So everybody is okay?
Yep, just gonna practice.
Okay, thank you so much, and you have a good. Okay, one other thing is that you see that our course evaluation link, you should see it in email or in D2L. Okay, so please complete it. Okay, and as every professor does, I tried my best to represent this course content. Actually, this course has a lot of topics. Okay, actually, only object-oriented programming could be a course, complete course, a semester-long course. Okay, then we could have more time to discuss this. I tried my best to present many complicated topics easily, and that is your evaluation. Okay, so I wish then you will rate me positively. And as a human being, everybody has limitation. I did have many limitations during this pandemic time, but I tried my best. Okay, and I wish you good luck. So in the summer, I will be teaching data structure course, and fall hopefully I will be teaching data structure and algorithm course. If you take this course, I will see you again. Okay.
Thank you.
Thank you. And next, do we need to meet our next week? So next week we have a review and wrap up. So if we want to review, we have to meet then maybe for short time. If you have any question, we'll meet for maybe at least 30 minutes. But I'm not coming to actual classrooms. Like today, I came at office. In the morning, I came here, but still I'm not in my office. I didn't go because last time there was 2 students only. Yeah, I will join online, either from home or from office. Okay. And thank you so much. And you have a good good evening, good day, and then good final exam. Okay. Bye bye.
Thank you.